release. Don't worry, don't worry. So I was pretty intrigued by this release of ChatGPT Pulse, which is, if you don't know, every morning ChatGPT can use all of your chat logs and come up with a set of like news, trends, or some sort of summaries for you. So it's basically AI working overtime on your behalf and delivering personalized responses to you. And while that sounds very half-baked, there was a lot of critique and a lot of commentary about it in the news circles. People were worried that these systems are kind of starting to trickle in your daily lives. And because a lot of people use these systems on a daily basis, it only made sense to kind of personalize these systems towards you. But this is not the only way people are using or kind of deploying these personalized systems. This was, I think, yesterday's release where Meta came up with this new AI ecosystem for advertisers to deliver personalized advertisements to you. So think about all the time you've thought Instagram is listening to you. This is going to go beyond that. You're going to get advertisements, imagery, content that is all personalized based on your interactions. So there's a lot going on in this space, and we can save time in the end to debate about whether or not this is good. But for now, I'm going to talk about how this actually happens. So what are some common signals that these people use for personalization? One common signal is called demographics. So these are basically your attributes. If I treat a human being as a profile, then these are attributes that belong to you. So your race, your gender, your nationality. And there's a lot of efforts to very systematically and in a principled way collect this information. So if you've heard about things like the census, surveys, global surveys, there's a very popular one called the World Value Survey, which has a lot of rich user demographic data about your occupation, your dad's occupation, how much money you earn, what is the social status. And a lot of this data is collected to ultimately make trend predictions. So a lot of the times when you think about GDP and your economy and those things, they all rely on a lot of this survey data, which hinges on these demographic attributes. There's also interaction history and conversations, and a very common example for this is if you've ever used the memory feature in ChatGPT. So whatever you're interacting with and whatever conversations you have, all of this interaction history is a lot of rich user signal that these AI systems are now using to personalize responses to you. And apart from history, there's also a lot of cross-domain activity. So this is not, I would say, this is not directly interactions that you have with the AI system, but this is interactions you have apart from the AI system. So a very good example of this is this paper by Umar from Stanford, which is called General User Model. This kind of won a best paper honorable mention at UIST this year. And what they do is basically they build a system which can observe your computer use activity. So they have an extension which can kind of observe your computer use activity. What kind of web pages do you go to? How much time do you spend on each web page? Whatever information you can gather from that, and then use that to give you more personalized inferences, or kind of use that to build a more holistic profile of you. So but overall, these signals, whether that's demographics or interactions or even cross-domain activity, these signals are very tricky. They're tricky in two ways. Getting a lot of good quality user signals takes a lot of time and money. And this is not me coming at you again by telling, oh my God, data collection takes time. This one genuinely takes a lot of time. For example, world value surveys happen in waves, and each wave lasts 2 years. So the current survey that is being conducted is from 2024 to 26. If you've never participated in a survey, this is a very good one. Participate in it. I've signed up for it as well. And this kind of richer user data takes about 2 years to collect. Now think about it. If you have a language model that is trained on a lot of these demographic or these kind of user data from 2 years ago, things change on a pretty monthly, weekly, daily basis. So how do I expect that this kind of data collection speed is going to catch up to the demand of these personalized systems? And second of all, even if we do have good quality user signals, there's a lot of less information. There's very less studies yet done on when are such personalization systems actually useful. So when are these signals actually useful for us? And this is a very good study from some folks at AI2 at iClear last year, which showed that if you use some of these personalization signals, your models may behave in a very unlikely way. For example, they asked ChatGPT to adopt the identity of a physically disabled person. So that's the user signal. And then they asked the language model to do a math question. And ChatGPT responded, as a physically disabled person, I can't do math, which is incorrect, it's biased, and there's a lot of discussion about it in these communities as well. So there's a lot of discourse happening, but less consensus on when these signals are actually useful. So for the purpose of this talk, my agenda is split into 3 parts. I'll be spending more time on the first 2 parts and less on the last one. So the first one is one of our works where we talk about how simple low-cost signals work when we want to personalize for different people and whether they can actually work as expected or not. And this was one of the works I presented at ACL this year. Following that, I'll be talking about a very simple and cheap user signal that we can obtain. And it's surprisingly cheap. I'll talk about how, but you can use user rationales or explanations as an important user signal for personalization. And lastly, I'll conclude with some exciting stuff I'm doing right now, which is going to be about some new user signals and how are these signals used and some more interesting observations that we have so far. So the first part of the talk is the following. Now, let's consider a setup where you are asking your favorite language model a question. Why is the sky blue? And if the model doesn't know anything about you, it's going to make an assumption about your knowledge level. So the model probably answers things like selective scattering is proportional to the inverse fourth power of wavelength. But this assumes that you know what wavelength means, what selective scattering means, what's the inverse fourth power. So it makes a lot of assumptions. And how do we as users fix it? We just tell the model simple instructions that, oh, hey, I'm in grade 8 and I'm studying for my physics exam. And now, can you give me an explanation for why is the sky blue? So this kind of very simple demographic information is a very low-cost prompt-based way to just personalize model responses. And in the past, some of these simple user signals like demographics have been widely used. And I have an asterisk here because I mentioned demographics in themselves are pretty tricky, but for the purpose of just using and prompting language models, it's pretty easy to just add that in the instruction for the model. And a lot of people have shown that this was a new RIPS work from last year, which showed that if you add these kind of simple demographics in the instructions or the system message of the model, you can get some sort of personalized responses. And they phrase it in a very fancy way. They call it personalization by system message generalization. I call it instruction following. So the model is just instruction following. It's taking your demographic attribute and giving you a personalized response. And it's not only as a methodology, it's very popular, but it's being used everywhere. So there are people that are using this way of personalizing language models in creating social simulations. This is a pretty interesting work, again, from Stanford, which talks about how you can use these personalization systems to simulate societies. And then you can also do it to generate synthetic data. So you can scale up a lot of this prompt-based, simple, low-cost signals to get a lot of synthetic data. And what do you do with the synthetic data? You can train other language models with it. So Tulu, which was OpenAI's recent Almo 2 release, actually uses this way of persona prompting to get more synthetic data for different people. And in this particular work, I want to question how effectively can language models actually personalize responses with only these simple and low-cost signals. And something I do want to do in this talk is situate ourselves in a domain that's a little bit more constrained and talk about education as a domain to study this question. So I'll be talking about this education setup where we have why questions that need to be personalized for people with different educational backgrounds. So on a high-level overview, in this work, we have a tiny benchmark in current standards of around 13K why questions that we curate. And all of these why questions can be used to personalize responses to different people with different educational backgrounds. And then we collect explanations that are personalized towards different users. We do it with a lot of language models. For the purpose of this talk, I'll be talking about GPT-4. We have a lot of cool human baselines and a lot of web-retrieved explanations as well. And then we do 2 evaluations of it. First, we study how well are these models actually personalizing these explanations? And 2, how useful are these explanations? For the purpose of this talk, I'm just talking about the first one, but more details are in the paper. So we start off by collecting this benchmark called Eli-Y. If you guys are chronic Redditors like me, you'll know what Eli 5 is. Explain like I'm 5. So it's kind of derived from that. And we have this really cool cognition paper that talks about explaining to people with different educational backgrounds. So we pick that cognition paper, we have some sample questions that they use in their study. We seed that to GPT-4 and we overgenerate a lot of questions. This is a very common way of generating synthetic data these days. And we also have some questions that we pull from textbooks from children, from children's classrooms and a lot of other sources. But in general, we have this like larger set, overgenerated set of 30K questions. And then we do a lot of deduplication, removal, removing similar sounding questions. And then we also remove questions that sound very niche. So they are basically hard to tailor towards different users. So for example, questions like, why do DNA strands run from the 3 to 5 direction? Why is quantum entanglement paradoxical? In order to personalize the responses to these questions, somebody needs to know what quantum entanglement means. So it's very hard to actually personalize this response to like people with different educational backgrounds. So we filter these questions out, we do some cleaning, and we end up with a bunch of 13K questions equally split between STEM and non-STEM domains. And these are some examples of what these questions look like. So there are across multiple disciplines. Why do people love mysteries? Or why were dinosaurs so large? And we can basically tailor responses to these questions to people with different educational backgrounds. So now we actually do that. We generate these personalized explanations. We get these low-cost user signals, which are basically educational backgrounds. So let's say we want to generate an explanation to this question, why is the sky blue? We give that to our language model and give a very low-cost signal, like generate this for a high school student, and then we define for the model what a high school student means in the US, and we generate some explanations here. We do that with 2 more educational levels, like elementary, high school, and graduate. And now we want to evaluate how well can the model actually personalize these explanations. Before that, we have some other baselines that we generate. So there's a default setting with no personalization, and there's a web retrieved setting. Now, this is basically pre-Gemini. So when Google used to give a featured snippet whenever you used to ask a question. So these are basically web retrieved questions from existing pages. So this is not AI summarized. So we also have some of these explanations in our pool as well. And my favorite part of this project is basically having a human baseline of these personalized explanations, which is basically we ask people to do the task that we made GPT do, which is generate personalized explanations. The way we do it is we have a given question, we give that to lay users, and we tell them, you know what, go on the web and get us explanations to these questions and give us sources and tailor the explanations to these questions to people with different backgrounds. So what we could see in some of our data collection efforts was a lot of these users getting us elementary school explanations, high school and graduate school explanations. The graduate explanations were mostly from journals and research papers. The elementary school explanations were from Reddit, the Eli5 subreddit. The high school ones were from blog posts or public, I think, communications as well. So we also had humans do this task as well. And now we wanted to study how well can these explanations match their intended educational background. So what I mean by this is our explanation. There's an instruction that is used to generate that explanation, and that is called the intended educational background. That's what I want from the model, and that's the signal that I want. But there are people who are reading this explanation, and the person who's reading this explanation thinks, oh my God, this seems something a high school student would know. So this doesn't really seem graduate. And that's the perceived educational background that we get from an explanation. So in a more specific manner, our research question is, do these perceived educational backgrounds match the intended educational backgrounds for these explanations? And we do a very neat user study to do this. Our user study involves having the question that we provide to GPT-4. We have these explanations. We recruit a lot of participants. They have for like about 400 questions. We ask the participants to assume the role of an educator. We have participants from different educational backgrounds, and we're telling them, okay, now you want to find who is an appropriate reader for an explanation. And these participants basically have to just choose a group that they perceive as ideal for this explanation out of the 3 given. So in this case, the participants select something like high school. although the participants are unaware of what the intended educational background is. So we're kind of hiding that information. They don't know what instruction was used to generate this explanation, so that we can get like cleaner annotations and then compare these two signals together. So in the end, it's a very simple observation that we get. So, but before that, we have some more nits about the way we do our evaluation. It's not super relevant. But in the end, what we do observe is that if you try to like just look at a simple accuracy match or just like a match percentage of how often does the perceived education level actually match the intended education level, it's only about 50%. And there's a huge drop for like, this is a significant drop for like this like STEM questions and non-STEM questions, and the random performance is like about 33%. So there's not a lot of personalization that the model is actually doing. And funny thing is that if I have lay users that I actually made them do the personalization task, they are able to do much better. So like just having these manually web curated explanations can get even better personalization than just asking language models to deliver this to you. So in short, if you just want an explanation to why is the sky blue for a physics PhD student, you probably don't need to go to ChatGPT for it. You can just search it on Google and get a better response. And this is pretty counterintuitive, right? But no, we actually see these signals in some of the text that these models generate as well. So we compute a lot of automated metrics from these explanations. So we have some surface form metrics, which is basically just in general sentence length, word density, how much vocabulary are they using, which is out of or like more specialized scientific vocabulary. We also do something called readability tests. Now, this is something psycholinguists came up a long time ago, which kind of can numerically quantify how complex or simple a sentence is. So it can tell you the grade level of a given sentence. And we also looked at like what kind of reasoning are these explanations using. So this is some terminology we picked from some psychology literature that looks at reasoning being more mechanistic or more functional. This is not mechanistic interpretability, by the way, but just the format of reasoning. And we kind of look at how these explanations fit into these different surface quantifications. And what you can see is numerically, these scores are different. So on a surface level, models are generating differently looking explanations. So it's not that the explanations are same, they are differently looking. And you can see that numerically. So if you were not a human-centered AI person, you would just prompt the model to generate these explanations, look at these quantitative values, and you'll be like, okay, the model's generating different scores, it's personalizing. But that's not true. That's not the true picture. And how you can tell is when you look at some of these metrics a little bit more in detail. So for example, we looked at the Flesch-Kincaid reading E-score, which is another readability metric in detail. We found that psycholinguists had come up with this bucketing or interpretation bucketing a lot of for these scores. So basically these scores range from 0 to 100. And from a lot of their user studies, they could calibrate what these scores mean in correspondence to different educational levels in the US. So we took these interpretation scores and we made a distribution plot. So over here, it's the distribution of Flesch-Kincaid reading E scores here. And these three distributions are for explanations generated for these three different educational levels. And then we kind of also highlighted the different buckets that psycholinguists came up in the plot here. And that's where you can see something interesting. You can see that numerically, these scores are different. So like you can see that in the previous plot, on average, you can see different scores, but distributionally, they lie within this bucket. The majority of them lie within this bucket of high school to college level, which means that just on a surface form, the model is generating differently looking text, which can kind of tweak these Flesch-Kincaid scores and get you a more complex Flesch-Kincaid score or a simple Flesch-Kincaid score. But when you actually look at interpreting what these scores mean, they also say the same thing, that the model is not actually meaningfully personalizing these explanations. And why does this happen? In order to do this, before I do that, this is also not something that just automated metrics tell. Even our user annotators mention the same thing. So over here, I have this weirdly looking Sankey plot where I have intended educational background over here and the perceived educational background over here. And you'll see some very interesting trends here. there are some explanations which were intended to be elementary but perceived to be graduate, which means we wanted a very simple explanation and it was perceived to be a PhD level explanation. It's kind of crazy. And on the other end, we have something similar as well. We have explanations that were intended to be way more complex, but they were perceived to be understood by an elementary school student. And that was where we found that a lot of these signals are kind of messy and not actually personalizing responses that well. And when we asked user annotators, why do you think that's happening? Something that annotators told us was that there's not a lot of enough details / sources to reach graduate level. Word usage is above elementary, but can be fully comprehended by high school students. So our user annotations also sort of confirmed what we found, that on a very surface form level, maybe the model is going to start using longer words just to mess up with some of these metrics to get you a more complex sounding explanation, but it might not actually be complex. And as a case study, we wanted to ask, why does this happen? Why does this happen that certain explanations where we actually wanted to get graduate level explanations, we ended up getting elementary level explanations. So a very simple case study. Our hypothesis was that these are explanations that go through something we term as perceived simplification. So we intend them to be more complex, but we end up getting more simple explanations. And why it happens is a pretty data-driven answer. So I come back to this subreddit again, which is an Eli5 subreddit. And as you would know, a lot of these models are trained on a lot of this Reddit data. And a lot of these questions that we have in our pool, of course, surface in this subreddit as well. And what we found was that questions that actually lead to perceived simplification tend to have higher similarity with questions in this subreddit. So in short, for example, questions like, why are dinosaurs so large? If you ask a PhD level explanation to that question, the model will most likely give you an elementary school explanation. Why? Because that question mostly occurs in the subreddit when it's asked in this context of elementary school. So I have not really seen a lot of PhD students ask each other, why are dinosaurs so large? Like, that's just not a question we ask in daily life. So it's a pretty cool study. So basically what we can see here is that all of these simple low cost signals are like not enough to personalize models the way we want. And that is basically the first part that I wanted to talk about. So on surface, the model that I talked about here and more in our paper are able to generate differently looking explanations. But these, when you actually ask people to come and evaluate them, they are only perceived 50% at the time, like 50% to be matching with their intended education levels. And this is also something we see from these automated metrics, specifically metrics around grade level readability. And we found that this mismatch probably happens because all of this personalization is actually just instruction following on a very surface level. And it's very, very easy to just break through it using these simple user signals. And now we move on to the second part. So we mentioned, sorry, one second. So we mentioned how using these simple low-cost user signals is leading to only surface level personalization. So any natural next follow-up question can be, what do we do now? How do we get richer signals? And in this part, I'll talk about using user rationales for it. So I'm going to talk about going beyond surface level personalization. And I'm going to switch gears and move out from our domain a little bit. So move out from education to something people use a lot in census and population modeling these days, which is opinion prediction. So let's say I have a given user and I'm trying to build a persona of this user. And I mentioned earlier, we have access to a lot of a lot of low-cost signals, in this case, demographics, which is basically age, region, education, marital status, etc. And in our task here, we want to model what this person feels about different topics, or just like get an idea of their opinions about different topics. So we have a question. Let's say in this case, the question is about, what do you think the future of the United States is 30 years from now? I should have changed the question. I think it's not politically okay right now. But anyway, what do you think is the future of the US 30 years from now? And then what we can do is use this kind of user signal and prompt the model to get a response for this. So in this case, the model thinks that this user would be very optimistic. But the actual data, or the actual real user for which we have this kind of demographic, doesn't actually align with that response. So this is basically the task setup. And this has been very popularly done in a lot of work so far in like opinion modeling kind of tasks. This is a very famous paper which proposes this data set called Opinion QA, which has the same setup. And then there was some follow-up work where people said you can actually go beyond the surface level personalization. So apart from the demographics, what I can do is add some interaction history. And in this case, I call them judgments. Or you can, if you come from a more LLM community, you can call them in-context examples. So these are basically in-context examples, judgments, past history that I can collect about the user, which takes time. Demographics are easier to get. You can just add them to the persona. And what we can do is do our same opinion modeling task and get a response. And this is also something some people have done, which showed that a lot of people share demographics across communities, but what differs is the opinions or the in-context experiences they have. And this helps go beyond surface level personalization. And in this project, I wanted to ask, can we get even richer signals for personalization? Can we go beyond demographics and judgments? And I wanted to go back to this example of this person who has this demographic and has this opinion or this judgment. The public education system will get worse in the US in the next 30 years. So that's the opinion that they hold. And as we people do a lot, I was thinking about, why does this person have this particular opinion? Like, what actually led them to have this opinion? And if a side note, if you are from psychology, you will know about this theory called folk psychology, in which a lot of us try to rationalize what someone else is doing. Like, I think about, oh, this person did not get lunch to campus because they're probably trying to save money, or they're trying to eat healthy or something like that. So we always try to rationalize other people's behavior. And that's exactly what I was thinking about. Like, why does this user have this particular opinion? And this can happen because of multiple reasons. Maybe this person's monetary status is influencing that opinion. Maybe they are thinking, public schools will get so expensive. How will I be able to afford that in my income? Or maybe because of the location, because they're located in the West Coast, they think, oh my God, California is going worse. Public schools are prestigious and they're degrading. Or maybe it's because of their age. They think kids these days are glued to their phone, so public school education is not going to be helpful. So anything in the user's profile or in their demographics can actually inform this judgment that they have. And this is what we call rationales. So like rationales can often shape user judgments. So in this case, if I have this particular opinion about the public education system getting worse, this is one particular reason this user has. So this user felt that as a retired professor from the university in the West, I've had a front row seat in the slow decline of public education. And this is something which can be added as signal back to this kind of in-context examples that we're using. But here's the catch. And this is where I come back to rationales being a cheap signal, because it's not cheap. Existing user data on a lot of these opinion, value, preferences, you will not find rationales that people give. So people often do not have time to type out explanations for why they think a certain way, not in the way as we NLP people collect data. So there's not a lot of data to get these explanations. So like, how do we even go about it? And there's a very simple solution for this, which is our framework called PB&J. I love PB&J. So it's basically, let's say we have this user, they have these demographics, and they have a judgment. In this case, the judgment is, I do not believe advances in medicine can help in humanity. I think I took very controversial judgments. And what you can do is take these demographics and judgments, pass them through a language model as just generate a rationale. I know people are going to come to me about why are you making language models generate rationales, but they're pretty good at it. However, these are synthesized rationales. These are possible reasons for why someone would have this opinion, but this is not faithful to actual user reasoning. However, this is a good rich signal. And what you can do is simply add it back to these judgments in your in-context examples and get responses. And it works really, really well. And this is just one way you can synthesize these rationales. If you want to go a step above, you can do something that we call scaffolding, where I mentioned different people have different reasons to have certain opinions. So you can model these kind of different rationales. So in this case, we have the user talking about their experiences, about why, or the language model synthesizing the user's experiences for why they hold a particular judgment. and these experiences kind of look like, our prompt for this kind of looks like this, but you can have the model use any scaffolds. You can have experiences, you can have personality traits, world values, belief systems. All of these can be used to synthesize these rationales that can eventually be very valuable, low-cost signals that you can add to your in-context examples and then do prediction and get more personalized opinions about this person. And yeah.
So going back to the rationales, you did mention that these are not faithful to the user.
Yes. Yeah.
Is it possible that you give multiple rationales to sort of give the model that
More picture of
like a more holistic picture that these could be
possible reasons, but not the exact one?
Yeah.
That's a great question. We do have some experiments in the paper for that. I won't be talking about it, but yeah, that's definitely something that can be done.
So giving multiple rationales, even if they might be a bit divisive words.
Yeah. Yeah, that can work. Yeah, according to our results. So for the purpose of our tasks, we have the opinion QA task that I was mentioning. It's just a simple opinion prediction task. And we wanted to do something slightly different. And it was a movie rating prediction task. It's a little bit different than opinion, kind of more politically charged data sets. So we have this task where where the model has to predict what is the rating this person is going to give to this particular movie, given all of this context about the movie. And some more details, we phrase all of these questions as a QA task. So we compute accuracies. And for each person, we have 8 in-context examples or 8 judgments that we use in the persona. And then we test them on 10 questions per user. So about 7,500 data points and around 1,000 data points for context. So baselines. So in this case, you'll see opinion QA and movie lens accuracy numbers for 2 different models. One is a larger model that we prompt, and one is a smaller model we prompt. There's no fine tuning here at all. And these are some of the baselines that we start off with. These are proposed in the opinion QA paper. This was proposed in the follow-up paper that I'd mentioned. And what you can see is that if you don't give any persona to GPT-4 particularly, it can abstain a lot, almost like 57% of the time. That's because if you ask the model, what is your opinion about the US in 30 years, the model will just not answer it. But you can easily circumvent that when you give more cheaper signals like demographics, or in this case, interaction history. And as you would have guessed, because I'm presenting this, we do better. And we have basically all of these setups just augmented with rationales. So this is an augmentation with no scaffold, so just generating a rationale, or you can add additional scaffolds about experiences, personality traits, basic human values, world beliefs, etc. And we can see some really significant improvements, like about like with GPT-4 particularly, it's already very good on opinion QA, and just seeing like a 5% significant jump over 7,500 data points is pretty significant. And what we can see is like adding rationales is pretty helpful, and scaffolding them improves performance even further, especially for like other data sets like movie lens. I think I could see that from like 15 or 22 to like having 30% with just adding world beliefs as some sort of scaffold for your rationales is pretty helpful. And mind you, all of this is synthetically generated, so it's really cheap. You don't actually need to collect this data from users to personalize better to them. And some examples of what these look like. So I go back to this judgment where this user felt they are somewhat dissatisfied with their current job or career. So this is a rationale that the model generated for experiences. So they refer to their degree, their age, synthesized a couple of things which were not there in the demographics. For example, I found that what I value is not status or power in work. This was not present in the user's persona details or data at all, but this is something that the model could synthesize, and we could just use it to get better responses for them. And similarly, we could synthesize, or in this case, infer personality traits of this user. So this model just synthesized how this user would be in terms of extroversion, conscientiousness, and neuroticism. And these are just different axes in which we measure personality of people. And this model just synthesized or cooked up a rationale, which was pretty helpful in getting more personalized responses for these people. So before you come at me and ask me, this seems a little bit problematic. Let me just tell you, it's really, really cheap. And I'm coming to that because we do a lot of experiments with even human written rationales. So what we do as a part of this study is, as a part of this particular project, is we took a subset of questions, about 30 questions from Opinion QA, and we recruited 100 annotators, each with different demographic attribute. And we asked annotators to answer a split of these 30 questions. So answer 9 questions, and also provide your particular explanation. So this is when we're actually going through this whole month and a half to 2 month long process of collecting this data from users and asking them to also annotate more data for us. And this is where you'll see human rationales are pretty good. So if you have the time and the effort and the money to collect user rationales, that's going to get you the best performance across. So this is for the same 30 question split that I'm talking about, the same version of that table for this human rationales. But if available, human rationals work well, but having some sort of scaffold synthesized rationals can come close. So in this case, when I do t-testing over these around 1,500 instances that I test, no, yeah, 1,500 instances that I test, it's not a significant difference. So 46 and 48 is not significantly different, which means have access to user data, use user data. Don't have access to user data, cook up some really good quality synthetic low-cost signals that can really help with personalization. One thing that I had mentioned was that a lot of times this interaction history or these judgments are really hard to come by because they take time. But demographics are easier to record. And a lot of people, the way they record it is like in the beginning of every user study, they collect a pre-survey where you can collect what's your background, what do you earn, and stuff like that. But any sort of judgments or interaction or in-context examples take time. And that's where we see that having some sort of synthesized rationales can help really, really well when you have limited number of judgments. So in this case, if you look at the green and the orange curves here, with just 2 rationales, the method which does synthesizing of rationales can do even better than say using 16 rationales and no, 16 judgments and no rationales. So you can get a lot of bang for your buck if you say just have two judgments or 1 judgment. You can do a lot of synthesis with it, add that to the persona, and that can help you do personalization even better than say having 16 in context examples, but no rationales. And what we were ultimately interested in was that does this kind of synthesizing, can it lead to any unintended biases, which is basically because these models are trained on, because there's a lot of work shown on how these models are biased to certain subcommunities, we wanted to see whether it is actually happening or not. And in this plot, what you can see is the method that does not use rationals and just demographics and judgments, and then our method with the rationals. And we tested on a lot of splits of different demographic attributes and a lot of different demographic fault lines. And what we see is that even when we rely on synthetic rationales, we do not hinge on any particular demographic fault line. So it's not like only white male attributes are doing better. It is either you perform the same as the baseline or you see an improvement, but you don't really degrade if you do any sort of synthetic rationales here, which is pretty interesting because ultimately we do not, ultimately the whole purpose of personalization is for all. So it doesn't make sense if it doesn't work for certain subcommunities. And now that I've talked about cheap user signals and synthesizing quite a lot, collecting these user signals from real users is still an active area of research. And something we did right after this project is do just that. So we had around 858 participants with a very good stratified split of demographics. We made them do public opinion surveys. We collected a lot of free response explanations. And we also made them do personality tests, get richer amount of data and see. And this is public. This is going to be presented at EMNLP soon, and it's public at Apple. And you can play around with this data and get to know more about it.
Sorry to interrupt. I'm just curious. I feel like this PBNJ framework looks like a lot like a prompting framework that encourages the model to think more. So have you tried other baselines like just simple COT to see whether that also helps with it?
Great question. I think you're a reviewer too. I'm kidding. I'm kidding. That's a great question. So we do have experiments in the paper where we have compared like more thinking-based baselines, like chain of thought, more like reasoning with or without scaffolds. You'll see it doesn't perform that well because my hunch is that chain of thought is more instance level approach. So for a given question, you want the model to think about like how would this user respond to this particular question and then give an answer. What we're doing here is not post hoc. It's not a post hoc rationalization. It's more happening on the persona front. So just free form rationalize about the user and then just do simple QA after that. We do have some more other baselines about, I think someone was questioning similar to you said. So this seems like thinking. So doesn't it mean that if you let the model think more, it's going to do better? But we saw that token length, for example, thinking token length was very low for human written rationales and very, very high for synthetic rationales and even higher for chain of thought. So it means that it doesn't matter how many tokens you think for. It matters what's actually present in those tokens. So if you have good, dense signals from humans, even if it is less number of tokens, it works better.
Thank you.
So we have this data set, feel free to use it. So some quick takeaways is that in order to move away beyond surface level personalization, we look at some of these richer signals. And rationales are a great means to use that. I am a firm believer of like explanations and rationales is such a rich signal to use. And if collecting is not possible, perfectly fine. You can synthesize some of these signals. And while they may not be faithful to actual user reasoning, some of these signals can help really improve personalization performance, especially in cases where some of this interaction history is limited. And I know I'm nearing the end, so it's a very, very quick part 3 where I'm talking about some of ongoing stuff that I'm doing right now. And I guess like just a quick recap we've already heard, but all of the approaches that I mentioned had something in common. They needed some user data already. So the education paper that I talked about had some sort of low-cost signal, some demographic that I needed. You needed some sort of demographics, judgments, rationales, opinions, personality tests. And a common question in personalization is often, how do you get useful signals for a new user? Now, it's a new user. I don't have any data about you. How can I get richer signals about you without making you do like a whole survey or something like that? And this is when one thread that I'm currently working on is learning to ask questions to elicit these user signals. So I'm just going to talk about a quick pipeline of what we're doing, but we have this setup where we have a user. It's a new user. We want to personalize for this user. So what we do is we have an assistant initiated conversation. So this is a conversation that an assistant will start with you and do a conversation. And basically, it's just a free form conversation. It can run as long as the user wants. And what we want is that the conversation should be in such a way that we can infer something about you. So this is a task of, say, book preference prediction, for example. So what I can do is make sure that the assistant can ask you questions that can get the most amount of information from you. So for example, what kind of books do you like? How similar are you to other readers? What are your personal preferences? And all of this data I can fill in the back while I keep asking you questions. And then I can do some sort of, and this doesn't need to be prompt based. This doesn't need to be zero shot. You can actually learn. You can actually make an assistant learn to ask good questions and learn to ask to fill this user profile. And in some of our preliminary experiments, we see that if you just use like an off-the-shelf GPT-4 model, it's not that really good at collecting these user signals via conversation. But we can actually train much, much smaller 7B models to do this task way, way, way better. And this is just to elicit signals for new users. But also, there is a case where we want to fill in the blanks about users. So like, what about, I have some information about you, but I don't have some other information about you. So in this project, we have a setup. For example, I want to know what are some fun things to do in DC. So I can have multiple questions that I need in order to give you an answer for this. So for example, what type of activities does this person like? How old is this person? Do they have a car? Blah, blah, blah. And then I have this user profile or sort of user information, which is in the form of a database. I ask only the relevant questions. So the first 2 are relevant questions. I can ask that to the database, get you an answer. So this is a good way of using these signals. However, what about a case where you don't have certain information? So for example, going back to my education example, if I want to explain entropy to someone for whom I don't have any idea about, maybe I know about what physics topics they know, or maybe I know about the education level, but I don't know about the depth that this person wants in their explanation. So this is a gap in my database about them. So what I can do is I can identify that this gap exists, find this question, and then learn to ask that question to the user, get a response for that, and then fill in the blank. So this is more of like a middle ground to the new user task that I mentioned. So this is more of like, how do I fill in the blanks for a user for whom I have particular information already, and I just want to fill in new information. And as a last thread, something that I wanted to share was sometimes it's it's surprising that you don't actually even need to provide this information. And a lot of these user signals can actually be extracted. And I don't want to stress anyone out, but this is kind of pretty prevalent. So I know that a lot of us use AI systems on a daily basis, right? So I was reading this UN University report about like how many people actually use ChatGPT on a daily basis, and just like the 2.5 billion number just like messed with my head. And then OpenAI's official reports of like having 10% of their users using ChatGPT on a daily basis. All of this was really concerning. And some of my friends and I, we were like thinking about, well, if you don't tell a model about who you are, can the model just extract these signals from you? And the answer is yes. The question is how fast. So I just made this plot last night, but in this plot, I have the number of turns that you take with an assistant. And on these three plots, I have basically how well can I predict your nationality, your age, and your gender from just conversing with you. And these are just, mind you, 5 turns of conversation. I have probably had 20 different turns of conversation per day with ChatGPT. And for example, for nationality, you can go on from like 10% to like a 25% of like accuracy in predicting your nationality in just 5 turns of conversation. And this is not even stratified. I think for some people who are from some more overrepresented demographics, this is going to shoot to like about 80 to 90%. The model can just predict these responses. So in short, there's a lot happening with these user signals, right? So there are some low cost, simple user signals, there's rationales, there's a lot of new signals like conversation, but sometimes people don't even need signals. Sometimes we can just extract that from conversation. And there's a lot of debate happening on whether that's good, whether that's bad, whether even we need personalization in this case. I would love to talk about more of that soon, but that's not what my talk is about. This is kind of more about user signals, but that's all. These are all my mentors and collaborators in these projects. Thank you.
I have another question about what do you think on the high level about the balance between personalization and the simple fancy behavior from LLMs? I feel like a lot of these, when you reinforce or when you enhance the personalization, you will also reinforce the syncopancy. So that will be also problematic.
Yeah, that's a great point. I think all of that kinds of comes down to wait, where did that go? Yeah, so all of this kind of comes down to like how people actually do personalization, you know. So the reason why sycophancy also happens is because there's an over reliance on the instruction that you're giving the model. So if you're telling the model, I want this, or I am this so and so, and I want this, the way these models are trained on these helpfulness attributes, they're going to be echoing your opinions more, and then basically try to personalize based exactly on those attributes that you have. So I think it's like a trade-off between how good an instruction following model is versus how much personalization / sycophancy you want. It's very correlated. And I think they are problems that should be studied together. But unfortunately, a lot of the cases where sycophancy is studied is like in over-reliance and safety and like those setups. We have some folks also looking at sycophancy and personalization, but that's a very, very ripe space. And I feel like part of that is just the way these instruction-tuned models are used. And if you're interested, I think that's a great space to do as well, to work on as well. Yeah. Oh, there's a So Maxine had a question. The part at the end about user signals being extracting is so interesting. Yeah, just one. Why do you think the LM generated rationals improve the result, even if the rationale isn't necessarily faithful to the user's line of thought? Is it just because the rationale is fairly likely to be close to what the user is thinking? That's a great question. I think that okay, so there are two things that are going on here. A, the way these rationales are used in just a prompt-based manner, and B, of course, there's similarity to user reasoning. So in the paper that I had mentioned about where did that go? Yeah, so the paper that I mentioned about where we collect these user signals, we have like an analysis that we do about how close these generated rationales are to human written rationales, and it is pretty close for like a lot of popular opinions, or like a lot of opinions that you can actually predict this. But it might just be that it gives the model enough signal to answer some of these questions that we are prompting for, but it may not generalize well. So I think the answer is yes and no. It might be more close to what the user is thinking about, but also it might just give some signal to answer a downstream question, even if it is not related, but it may not generalize to other domains or something like that. So that's something we observe as well. So not all generated rationales are similar to user ones, but the few that are pretty predictive for downstream opinions. That's probably the nature of this opinion prediction task in general, I guess. On chat, no.
This is a good time.
Okay,
Finish doing this.
awesome.
Thank you so much for coming. That was really Can we stop? So you're good.